Now, it's very important to understand the difference between open redirect vulnerabilities and server-side request forgery. In an open redirect vulnerability, the result is the user is going to make a request to the evil website specified in the malicious URL. Whereas in an SSRF or a server-side request forgery, the target web server is going to make the request to the other server, assuming the evil server or any other kind of server. So what's happening in an open redirect vulnerability? We're sending a forged request to the target vulnerable website with a URL, and as a result, the target website is actually sending a response back to the user, telling the web browser to load the website we specified. Now I have the load here just in red because there are a number of ways where a web server can tell a web browser to load a different website. So what's causing the web browser to load the specified website is the response that is coming back from the target website as a result of the initial request that the user sends with the URL specified. Therefore, to have a better understanding of this flow and how this is working, a good idea is to come back to Burp and enable the responses. So we're going to go to Options and click on Intercept Responses. We covered this before, so that we understand what exactly is being sent in this response that is causing the web browser to load a completely different website. So let's go back to Burp and let's go back to the interceptor. I'm going to keep it off for now because I just want to go back to the original website before I exploit it. We're going to change this to return capital URL. I'm going to copy it so I can load it easily in the future. I'm going to turn on the interceptor and we're going to hit enter to load it. And as you can see, the initial request is here. It's a GET request to the Go file. The return URL parameter is set to google.com, to what we specified. So far so good. So this is this request right here going to the server. So that is fine. We're going to forward it. And as a result, we're getting a response. This response is coming from the target website that we're exploiting. And as a result, if you look in here, you can see that it's specifying the location header. And it's setting that to the URL that we specified in our exploit, which is google.com. And for some reason, it's appending hash type is equal to 0. So we actually never specified this in our payload. We never specified that in here. But for some reason in the response, it's being appended to the specified URL. Now, because we see an equal sign, this means that this is another parameter that we can test, and therefore we should carry out more tests by submitting the type parameter to the URL in here. Now, if we stop the interceptor, you'll see that we will actually be redirected to google.com, but the hash type equals 0 is still being appended to the URL. So this is actually something that is being sent back to the user. So the user is asking for google.com, and the response, instead of it saying load google.com, it's actually saying load google.com hash type is equal to 0. So this is another parameter that we can test for other vulnerabilities, and we can manipulate just to see what impact it has on the result. So we're going to go back and go back in here as well, turn on the interceptor, load the same URL, and instead of setting it to 0, I'm just going to set it to 1. So it's always good to make small changes instead of starting to type text and starting to test for all of the other vulnerabilities that we know, like XSS and all of that. Let's just keep it as simple as possible. Let's just try to understand what this type parameter does. And instead of its default value, which is 0, we're just going to set it to 1. I'm going to hit enter. And we're going to see the initial request. There's nothing strange about that. And here's our type parameter being appended to it. So that's good. What we're interested in is the response. So we're going to forward, and we got our response now. And this time, as you can see, the response is a bit different. So this time in the response, we actually have some JavaScript. So changing the value for the type parameter in here resulted in this change in the response. So initially we actually had location header followed by google.com, but this time we actually have this script, and the URL that we're specifying is actually being placed in here. So whatever value we're putting in here after the URL is being put in here inside the two quotation marks, which is inside a script tag. So if we can break outside of this quotation mark, we will be able to execute JavaScript. But if you look closer just for one more second, you will notice that this is specifying a href. And we covered earlier in the XSS section that inside href tags, we can actually inject JavaScript without even having to escape anything, without even having to close anything. And as I mentioned before, it's always best to try to keep our changes as small as possible, because that way we have higher chances of injecting code or exploiting vulnerabilities. So instead of trying to exit this quotation mark and then injecting code in here, I'm going to try to inject code within this because we already have a href. And we know that we can do that by typing JavaScript : followed by the JavaScript that we want to run. And in this case, it's alert2. I'm going to keep the type equals 1 because we know if we set it to 0, the method is going to be set to header and we won't even have this script right here. So I'm keeping the type to 1 so that my code in here, the JavaScript alert, will actually be placed inside this quotation mark. And because this is inside the href, my JavaScript will hopefully be executed. So I'm actually going to drop this and I'm going to paste the exploit that I just created and I'm going to hit enter. And I'm going to turn off my interceptor because I want the result to go ahead. And as you can see, we have our first request, so that is fine. We're going to click on forward. And here is the response that is coming back to the browser. And as you can see, my code is being injected in here. But literally just looking at the code, we can see that this is not going to work. Because as you can see, we have our JavaScript in here. So that is fine and that is perfect and it should work. But the problem is we have these values being appended to it at the end. But these values are not JavaScript and therefore they will probably break my code. But let's forward it and see what happens. And as you can see, it didn't work. So again, as mentioned earlier, when we have values that are being appended to our code that we don't like, what we do is we put a semicolon to finish a JavaScript statement because that's the way that JavaScript works, and we put 2 forward slashes to comment the rest of the code so that anything that follows the exploit that I just added will be treated as a comment and will be ignored. So we're going to hit enter again. That's the first request. We're going to forward it. It's fine. That's our second request, and as you can see, we have this being injected in the href. This is normal JavaScript code, so it should work, and anything that comes after it, which is this part, is going to be ignored because it is preceded with the 2 forward slashes, which will set it as a comment, basically telling the browser to ignore it. So let's forward this, and perfect. As you can see, we got our alert message executed on the target. So now we have discovered a reflected XSS in this target website in the go.php file. So a lot of people would have left this once they discovered the open redirect vulnerability because that is an actual vulnerability and it is an actual bug and you will get a bounty on it. But as you can see, if you spend a little bit more time trying to properly understand the flow and exchange of information that is happening between the client and the server, as you can see, we managed to discover a very dangerous reflected XSS. And in this case, you have actually discovered 2 bugs instead of 1.